This is lecture 15 of CS47 study, computer organization. We'll talk about logic gates in this lecture. So what are the logic gates? Logic gates are the electronic components. Those implement the Boolean functions. Okay? Or like at the very basic level, these are the electronic component which provides implementation for Boolean operations. So we have let's say we have this AND operation, right? Boolean operation has three fundamental operation, AND, or NOT. We can have electronic component such that if we supply logic to that electronic component input as like 0 0, its output will be 0. If I supply 0 1, its output will be 1. If I supply 1 0, its output will be 1, and if I supply 1 1, its output will be 1. So that electronic component is basically implementing a OR Boolean functions. Now, question is how this 0 and 1 is represented in electronics world. I think in previous lectures, one of the previous lectures, I mentioned that logics are represented in electronic circuit as a voltage level, or you can say it's a presence of a voltage or absence of a voltage. So presence of a voltage in electronic circuit is treated as logic 1, and absence of voltage or a grounded state, as we say in electrical term, that means logic 0. Okay, so I'm supplying 1 and 0 to electronic component, mean I am connecting one of its pin, electronic component pin, to a power source or a battery, which gives me a positive voltage like 1.2 volt or something. Then we treat that as a logic 1, and the other pin of that same logic gate or electronic component, I am connecting it to ground, which gives me a logic 0. That's what we mean by logic 0, logic 1 in terms of electronic components. So logic gates are physical implementation of fundamental logic operation. However, fundamental logic gates are basically implements inverted operations. So we have fundamentally OR operation, but we can construct in fundamental nature as a NOR operation. And we have AND as a fundamental operation in Boolean algebra, but we can construct NAND operation more fundamentally in the electronics world. And NOT, that in both world, NOT is a primary operation in Boolean algebra. We can also fundamentally construct a NOT logic gate or inversion operation. So then from NAND, if I combine with a NOT, so that is output of a NAND, if I drive it to a NOT logic, it will give me a AND circuit. So no problem in that, having NAND, NOR, and NOT as my fundamental electronic component for logic operations. All right. There are two types of combinational logic gates. One is not combinational logic gate. I mean there are two types of logic gates. One is a combinational logic gate, other is a sequential logic gate. And in this class CS47, we'll be mostly focusing on combinational logic gates. All right. Sequential logic gates is a little bit more complex ideas, so we'll pick up that in CS147 or computer architecture study. Now, combinational logic gates are those electronic component whose output depends only on the independent input values. Means it has couple of inputs. Let's say it has a logic gate has n number of input. Okay, there are like let's say 10 or 15 input, and the function it implements inside it, let's say y as an output pin, which is a function of in1, in2, and in n. So its logic value, output logic value, only depends on the input values, nothing else. Okay. You might wonder what else could be there. Well, look at the sequential logic gates. The output depends on the current input value as well as a previous output value. Okay, so it's not a Boolean fundamental Boolean function, and used to implement storage and state elements. Again, those becomes a part of essential study in CS47. But just a sneak peek, sequential logic gates, its output is a function of in1 to in, okay, and also it's a function of its value determined in the previous computation. So ft plus 1, that value is essentially, that is, I'm computing the function, I'm computing the output variable value y at time point t plus 1, and that output depends on all my independent input, okay, and also the output that we computed in the previous step, ft, okay. So that's my sequential logic gates. So that's all you need to know for this class. Well, a little more deep into that, if you are interested. If you are not interested, you can probably skip these slides. We'll anyway pick that up in CS147 study. So instead of saying that this function is completely depending on the previous computation of ft, previous computation which is ft, we can kind of make it a partial, more generic definition, which is ft plus 1, let's say, is a logic function 1 which depends on xyz primary input and some old partially computed value gt. Okay, gt may be ft, that's fine, or gt may be a completely different function in general, where your gt plus 1, that function is another Boolean function xyz which also depends on its previous value. So f1 and f2 are combinational functions. T is a number of iteration and value of z0, like since there is a t plus 1 and t kind of term. So if we are computing g1, for example, where t equal to 0, then we are coming out of the term z0, which is known as initial condition. Just this is an FYI kind of stuff right now for this semester. Next semester we'll talk more about this one.